Here we have a geometry question. Okay, let's go with the question. So there is a figure given over here. So based on the picture above, determine the lengths of QD and QP. So we have to find the length of QD and also we have to find the length of QP. And also there is an important information we have about the figure. There is AB and QP are parallel because between AB and QP, there are two lines between them. So it represents, so the two line segments AB and QP are parallel. So AB is over here and QP is over here. So these two line segments are parallel. Since these two line segments are parallel and the line segment AD which intersects both QP and AB is called transversal. So whenever two parallel line segments intersected by a third segment which is called transversal, then the angle measure over here and the angle measure over here must be equal in measure because these two angles are corresponding angles. So when two parallel lines intersected by a transversal, always the corresponding angles must be congruent. That means they must be equal in measure. So the angle measure over here, the angle measure over here are corresponding angles, and they must be equal in measure. And also the same thing we have for these two angle measures, angle measure P over here, angle measure B over here. So because these two parallel lines is intersected by the line segment BD, so BD is a transversal and this one are corresponding angles and they must be equal in measure. Okay, here in the given figure, we can consider two triangles. One is a smaller triangle, QDP, and the other one is the bigger triangle, that is ADB. Okay, so for these two triangles, D is a common angle. So let's consider the three interior angles of both the triangles, triangle QDP and ADB. So three angle measures of the smaller triangle QDP are equal to the three interior angle measures of the bigger triangle ADB. So whenever two interior angle measures of one triangle are equal to the three interior angle measures of another triangle, then the two triangles are said to be similar. So here the smaller triangle QDP and the bigger triangle ADB must be similar. Okay, let's write the vertices in order. So first let me take the vertex A in the bigger triangle. So what is the corresponding vertex in the smaller triangle? Clearly it's Q because this angle measure are equal. Okay, so I have to write the vertices in order. Okay, now let me take the second vertex B in the bigger triangle. And what is the corresponding vertex in the smaller triangle? It's P. And the third vertex is obviously D in both the triangles. So here we have D, here we have D. So these two triangles are similar. So if two triangles are similar, then the corresponding sides must be proportional. Okay, so in the bigger triangle, I am taking the side AB first. So I'm taking the side AB. What is the corresponding side in the smaller triangle? So when I consider the vertices over here, so to get the side AB, I'm taking the first vertex and second vertex. I'm taking the first letter, second letter over here. So to get the corresponding side in the smaller triangle, I have to consider the letters at the same position, at the first position, at the second position, then QP. So QP is the side which is corresponding to AB. Okay, now I'm going to consider the side AD in the bigger triangle. What is the corresponding side in the smaller triangle? So AD means I've taken the first letter, third letter. So please take the same, take the letters at the same position, the second triangle, QD. So QD is the side which is corresponding to AD. Okay, now I'm going to take the third side, BD, the bigger triangle. What is the corresponding side in the smaller triangle? BD means I have taken the second letter, third letter. So here also I have to take the second letter, third letter, then PD. So BD and PD are the corresponding sides. Okay, now what we can do is we can substitute the known lengths. So do I know the length of AB? Yes, I know it's 18. It's given in the question itself. We can plug in 18 for AB. And for QP, I do not know. I have to find. So we can write QP as it is. And for AD, I know the length, I do not know the length for AD. So, but I know the length for AQ. So let me assume for QD, let's assume X. Then what is the length of AD? So it's X positive 9. So for AD, we can plug in X positive 9 over QD. What is the length of QD? QD is X. Just now we assume the length of QD as X. Okay, for BD, what is the length? So for BD, for BP, we have 15 and for PD, we have 30 centimeter. So to get the length of BD, what I need to do is I need to add these two lengths, 30 plus 15, it will be 45 centimeter, the length of BD. So we can plug in 45 for BD. And for PD, so PD is given, that is 30 centimeter. Okay, so I think we can simplify this one because for both numerator and denominator, we have the common divisor 15, greatest common divisor. Okay, let's simplify that. So 18 over QP equals to X positive 9 over X. equals to, when I simplify this one, 15 goes into 45 three times and 15 goes into 30 twice. So I'm getting 3 over 2. So here these three quantities are equal. Since three quantities over here are equal, if I want, I can equate any two out of these three quantities. Okay, so if I take the first quantity here, so I have an unknown QP because I do not know the length of QP. So it can be equated to the third fraction, because in the third fraction, both numerator and denominator are numerical values. There is no unknown in the third fraction over here. So we can equate this quantity and this quantity. We can solve for P. Okay, let me do it. So let me equate the first quantity 18 over QP and the third quantity 3 over 2. Okay, to solve for QP, first I have to get QP to numerator. Actually, QP is in denominator. So for that, we can take reciprocal on both sides. If I take reciprocal on both sides, I'll be getting QP over 18. On the right side, I get 2 over 3. Okay, to solve for QP, I have to multiply both sides by 18. When I do so, this 18 will cancel out. 3 goes into 3 one time, 3 goes into 18 6 times. So I'm getting QP equals to 2 times 6 is 12 centimeter. Okay, so in the given two lengths QD and QP, I got the length of QP, that is equals to 12 centimeter. Now let's find the length of QD. So for that, we can take the second fraction because there is unknown x, and it can be equal to the third fraction. So where both numerator and denominator are numerical values. Okay, so let me equate them. So when I do so, I'm getting x positive 9 over x equals to 3 over 2. Okay, so to solve for x in this equation, we can do cross multiplication. That is, the numerator over here has to be multiplied by this denominator. So when I do so, I'm getting 2 times x positive 9, and this numerator has to be multiplied by this denominator. So I'm getting 3 times x. So when I distribute this 2 to x and positive 9, I'm getting 2x positive 18 equals to 3x. Okay, to solve for x, I have to subtract 2x from both sides. When I do so, so this positive 2x, negative 2x will cancel out. I'm getting x equals to 3x negative 2x is just x. So I get x is equal to the 18. So we can replace this x over here by 18. So our aim is to get the length of QD. So the length of QD is 18 centimeter. So QD equals to 18 centimeter.